Every function has a domain and a range that we can state in different ways. We'll focus on using interval notation. The domain of a function is a statement about all values of x for which the function is defined. And the range is a statement about all values of y for which the function is defined. A function with an unrestricted range, unrestricted domain would have a domain of negative infinity to infinity, indicating that all values of x are part of the domain of that function. A function with an unrestricted range would have a range of negative infinity to infinity as well, indicating that all y values are in the range of that function. Then, as we look at specific functions, specific cases, we may have restrictions where that interval goes from covering all real numbers, negative infinity, to something more limited. In example 4, we're given a fairly restricted graph, and we want to define or find the domain and range of this function. We'll start off by identifying the domain. To do that, we'll look at the x values where our function occurs. For instance, if we were looking at x equals -3, the curve, the graph, never crosses over that line for x equals -3. So that would be outside our domain. In this case, we'll be looking at just this region in green. Those are our x values where the graph exists, where it's defined. So our domain would be close bracket -1 to 2 with an open bracket or a rounded parenthesis. Keeping in mind that that square bracket means that value is included as part of the domain. In this case, because we have that filled in circle when x is equal to -1, and we have an open circle when x is equal to +2, so we use that rounded parenthesis to indicate values up to but not including 2 are part of the domain. To identify the range, similarly, we'll look at our y values, where our curve exists, where our graph exists. So in this case, our range would go from a close bracket -4 up to 0 with an open bracket or a rounded parenthesis. So the smallest y value that our curve hits is -4. The largest y value that it doesn't quite hit but approaches is 0 because of that open circle. So our interval is indicating all values between -4 and 0 with -4 included. In example 5, we have what's referred to as a piecewise defined function. Meaning our function has a different definition over different domains, which is why we see sort of two different pieces of a graph with a jump or a break in the middle there at x equals 0. In this case, to identify our domain, we're going to approach things the same way. We'll look at all values for x where our graph exists. In this case, even though we have this break, we have this jump at x equals 0, where the graph is approaching y equals 2, and then it jumps down and continues on this lower portion. Since that point at x equals 0, y equals -2 is included, our domain would be -infinity to infinity. And our range would be -infinity to +2. In this case with an open circle, since we have, in this case with a rounded parenthesis, since we have that open circle at 2. So we're including everything up to but not including that point at 2. I'm going to erase what we've drawn here to look at a slightly different case, starting with this same picture, but let's assume that at 0, -2, rather than having a filled-in circle, we had an open circle. If that were the case, then our domain would update to now exclude values at 0, since our curve never hits x equals 0. So our domain would have a break, our interval for our domain would have a break. It would go from -infinity to 0, and then we would use this union symbol to join that with a second interval from 0 to infinity. This notation indicates that we have two different intervals where we can find that domain. Values of x that are less than 0, indicated by this first interval. Values of x greater than 0, indicated by that second interval. But at 0 itself, if again we're imagining we had this open circle here, the graph isn't defined at x equals 0, so we have to introduce that break, that undefined point.